found the right pressure here. Okay, and then because house air pressure has lots of humidity inside there, so it is valve here to drain the water. When accumulate water, maybe you can just, do you have any bottle, empty bottle?
It's a waste speaker, right?
That's too small, I think that big plastic one, the bench. You said water in there, but let me try. So let me open. Not too much. The good thing is this air is already filtered. Somewhat filtered. So some air has lots of humidity, but our system maybe they already filtered some humidity. So it's dry one. That's good. So anyway, and then okay. First pump, second wall, third one is bench one, bench air, right? So using this bench air, we're gonna apply this to the perfusion system. So we have two valve here, one for that, one for here. So this one is on, this air is on, is going to there. This one is off, because we are not using now. So whenever you need, you have to turn this on like this way. So I close here because we are not using at this moment. Right?
Yeah.
So this is valve, but before this valve, so this air tube, can you see tube?
Yeah.
This is regulated by here. So this one is PSI, maximum 3 PSI. So I found this regulator, pressure regulator from internet, which is allowed, this is the lowest I can control, the lowest one available online.
Okay.
So lower here, it's hard to find the one right one, but we usually use less than 2, around 2 PSI for that one, this one. Sometimes we may need to use 1 here, but lower this much is very high to regulate. This one, I try to, and using this knob, increasing, can you see here? Increasing, decreasing, but it doesn't go lower than 2 here, even I open here, maximum.
Okay.
So that's why it's very high, it's very difficult to control very low pressure thing. Right? Anyway, so what you need is when you, when you start the experiment, before experiment, you have to drain some, maybe this one is the thing. Anyway, you have to drain bleed some water from the tubing like that, right? Because you have to fill the water, best solution, whatever solution, in the tubing, and then removing any airs in the valve, right?
Okay.
To do that, you need to increase maximum in this one, like about 2 or more than 2.5 or 3, around 3. Increase the pressure to make the high increase too easy to draining something water. So now those pressure is connected to those tubing was connected to here, this one, right?
Yeah.
And then this one. Make sure you can see, you can hear.
Yeah.
Sound, right?
Yeah.
That air can make this high. So make sure first you have to check this one. If you are not using long time, you make sure this make air coming out here.
Okay.
Right? Yeah, because this one makes the pressure on the so first thing you check this one. Now air is okay. So the second one is where the air is leaking. So this one air is blocked by this one, right? So no leaking. And then here it's better to, if you're not using, block here because no leaking. And then you will use these two, right? So the water filled here, nothing, right? So first you have to, so it's not locked. So first make sure all valve must be valve must be clearly locked. Okay? And then this way you lock this one. Right?
Ah,
Therefore you lock. This is closed.
Yeah,
Off.
yeah.
So you lock. This one lock, all lock. But this one is leaking now because its air is coming in this way. To lock, you have to go this way. This is locked. So now it's all air was blocked. Right?
Yeah.
So and this one is valve. This valve is you may not okay. Okay. If the front one is hard to come in here, back one is easy to come in. So means back one is we call that is what is that? Normally back one is off, front one is on.
Okay.
So off means no. This one is okay. How to work is this one can clamp this tubing to lock the air. So normally backside one is no clamp. Front one is a clamp. Is that clamp? Something I don't know which one is normal. Okay, let's see. Let me see. Power. And then next one, the first one. You see. Let me see.
Oh, so that sound is the clamp?
Yeah, clamp. Yeah. This one. I think the first one is. Let me see. This one is now on, right? So I think the first one is on. So I have to double check. So two here, grooves here. Each one of this one is normally open and the other one is normally closed. So and then this can make switch on and off like that.
Okay.
So I think the first one we use mostly, the first front one we use, that is normally open. It's normally closed, I think. So okay, what I think the front one is normally closed. So when we didn't open the valve, that is front one is normally closed. So and then when you switch this one, and then the front one is open. So there is normal open, normal closed kind of state. You have to use those things. Okay, like door. Normally door is open.
Yeah.
And then that means the air or the flow is on like that. In that case. But if door is normally closed, now this switch can open those door. So this one, the front one is normally closed. The front one, normally closed. Okay, so it's closed. This is now open because it's on, right? It's open now. This closed. If I use the fourth one, it's hard to put here. Instead of that, because the front one is normally closed, so you have to turn on all the first one and then put this in here. Because now I open there, the first one. Normally, now it's open, right? And then you can just like this way. This is the way you install the tubing. The first one is also so here. Like now it's all off. It means normally closed. Here is closed. Without power, it is closed. So the front one is like that. So when you remove the tubing, you have to open, and then release, and then release like this way.
So while we do experiment, we need to release this tubing, not to put it in the first one.
First one you have to put here.
Yeah.
When you do experiment, it's on state, right?
Yeah.
Then you can push. You don't need. If you don't need this one, just leave it here and then close here. So this is the way you install the tubing inside there while this is on, and then you can off that one. So this is now closed. So when you do experiment, you need to perfuse this one, right? You have to turn on.
Okay, so no need to
They
remove
can make
this
water,
one.
and then this valve should be like this way. Close this one,
Okay.
and then it's on state, right? But like this way. So now this ready to experiment because this one is. So this one is to feeding the solution to right here, right? So So you should close this one, and then this is on state, on valve.
Mm-hmm.
There are two valves, this valve and this valve, right?
Yeah.
This valve is manual to install, to feeding or to loading the solution inside here. That is when you use this one, right? So when you do experiment, after loading this one, we have to close this part and then open this way, and then this one is controlled by here. Now that is ready for using this one, same as this one too.
So we don't need to remove this and do perfusion. We can just
Leave
put
it there because
Leave it
you
there.
need turn on and off by this way.
Yeah.
You know what I'm saying?
Okay.
So using this variable, you control the
Perfusion.
Perfusion.
Yeah.
same as two. Why I don't know why it doesn't show any sound.
Yeah.
Just
3 and 4 click, but 2.
Two
two
doesn't.
maybe
2 doesn't make any sense.
we have to replace this one. So don't use two. It's broken. Two was broken. Okay, use 1, 3. Okay, 1 is best solution, 3 is whatever your solution. Okay, so if I close, always close this way. If you are not using that one, and then leave this open. Then this one is here. Oh, sorry, I have to turn. Yeah, it's on. So after on, you have to put this into here. Okay, because it's on means it's open. So now that way you can install this inside here. Don't install this tubing when it is off. Does that make sense?
Yeah. It must be the light must be on before you install
This valve is okay. Tubing is here. Tubing is here. This valve, when it is on, it can be open here, and then you can install tubing.
Mm-hmm.
And then when it is off, it can be clamped.
Yeah.
It's normally clamped. All right.
The clamp kind of prevents like leaking.
Clamp can make the no perfusion.
Mm-hmm.
When it's on, means it's open. So it's normally this one is clamped this way. Off is like this one. Right?
Yeah.
So when you have to open and then install, and then make ready off this one, make ready clamp this one, and make ready for experiment. When you for this one. So when you do perfusion best solution, for example, you need on, and then this this whatever solution coming in to the.
So after bath session, we need to off it and
Yeah.
3. Okay.
So there are two different type of controlling valve. One is one press, okay, this one. So here power, nothing on, right? Latching, no, nothing, right? Momentary, these things, nothing, right? So only power, I just power on. And I didn't turn on anything.
Yeah.
That means you can turn on, and then meanwhile you can add another turn on, and then add another turn on. You can do that. So this one is you can perfuse this one. Meantime, you can perfuse this one and this one. And there is all three mixing.
Mm-hmm.
That's one you don't want. That one you don't want. You want to turn on, and then right after you turn on, if you press this one, you should be turn off automatically. So that is the way to do. I think latching, something like that.
Yeah.
Here, see latching. Whenever other press, the other one is off. That's a latching. Okay. So use latching for our experiment.
Okay.
Momentary means only press the time while you press,
Yeah.
and then it is on. But if release is out, off. That is momentary. Okay.
Yeah.
So momentary is only on while you are pressing. We never use momentary in our lab. So we use a latch in our lab. On and then switching other solution like this way. So latching is what we use.
Yeah.
Okay. All right, that's one, and then we have to. Okay, can you give us some distilled water? Yeah. This one should be distilled water.
Yeah, this one.
You have to replace.
Yeah, but
meaning-
this one.
Okay, fill this much.
Okay. I replaced them yesterday.
Okay, so here, see, something happened like this one. Yeah. If it is like this way, it's bad, right? So fill this much.
Okay.
fill this much distilled water. What is that?
It says 500 ml DMAP.
Email? Okay.
Can I trash this or use the same one?
No, we need a different syringe.
Yeah, different solution.
So it's cross-contamination happen. Okay. You have to be careful cross-contaminating. So don't use the different type of chemicals. If you use DMAP, you have to wash many times. And the syringe, absolutely, you have to change a new syringe for new solution. This is gonna be maybe PBN, right? Later.
Yeah.
So if you use distilled water, that's fine. But if you use some chemical, you have to be careful cross-contaminating.
Okay.
So here, later you have to label this one.
Yeah.
Okay, and then here, we install. I think 5 ml is okay because this syringe is 5 ml.
Yeah.
So this 10 ml is too big. Right, so now we can close the bottom, right? And then you can. It's air coming in because we have pressure here.
Yeah.
So you have to press as much as possible, and then try to remove the air inside the air. I just press maximum, and then remove air. Around this one, it's okay. Now I can close up. So I loaded a little bit over this one. Half over here, half over here. Okay, this one take like 2 days to bleeding this one. This lasts long. This much is a lot actually. Just think about it. Small amount one is bleeding out from the tip. This much takes like 2 hours, 3 hours, enough for your 1 day experiment. Same as here. So I close the bottom. So here, slightly here, U shape here. Don't make straight, too straight this one. Slightly U shape, U shape here. And then I'm gonna load this one, and then close this one. So this is ready to. This is the how load the whatever solution in this reservoir. Okay, and then I'm gonna turn on. Before you load this one, so here 1, you see here number 3, something like that, right?
Yeah.
What is it, number 2? You can say here number 3 okay, later. Okay? So here number, we label number here. 4, something like that, but make sure you use same tubing for same chemicals. This best solution, you keep use best solution for this number 1. Number 3, 2, whatever. If you use number 2 for certain like type of chemical.
So why it is indicating 2 in the?
I don't know. They switch from here to here because this one it was here.
So but when we click here, we need to do 3 only, right?
Yeah, because they control this variable. This tubing is that it doesn't matter.
Okay.
You can relabel.
Yeah, you can relabel. It's okay. But
Can relabel.
what you need is okay. First, unscrew this one, and then bring out. You see?
Yeah.
If I load again here, push, and then tight like this way, and then unload, unscrew, and then take out. This is how to load and unload. So what you need to this one is you have to drain fill the tubing here from here because here is some air in here.
Yeah.
So can I have small beaker, empty beaker? Yeah. Is it distilled water?
Yeah,
It's okay. So that way I'm gonna drain. So this on, right?
Yeah.
I'm gonna drain, close. This one I'm gonna close, and then this one is connected. This way you can see. Is that closed? Something wrong. Yeah, back one is actually we have to use. Back one is normal closed. Front one is normal open. So here I was wrong because the back side of this channel, back side of this valve is normal open, normal closed. The front one is normal open.
Okay.
So all this must be used. The back we use back one, not front one. Okay. So now let me turn on Okay, I close this one just because while I change this one, I have to close this valve. So here I'm gonna switch now. The front one is closed, right? And then this one is closed, normal closed, the back one. So now I will turn on number one. See, you see the dripping.
Yeah. Okay.
You can check this way. So now we have to use the back one. Same as here. Now I just fill the air. I remove all airs and then fill the solution entire from here to here. No air.
Mm-hmm.
And then you can link, connect this one back to here. How much? You can put this much. You can insert this much. Okay?
Yeah.
You can feel some if I push and it hits something somewhere, and then I cannot go further. So that is how much you insert. Okay, that is what I did for number one. Okay, let me just make sure number one is correctly, variable was correctly connected here. So make sure this was previously this was. This is bad.
Closed.
Yeah, right? Now, Rebecca, this is bad.
Yeah. It's
See,
bad.
It should be entirely in here,
Okay.
right?
Mm-hmm.
So now let's check any water dripping out from, because we just connect this one. The other one is no air coming. So let's see any water coming out. Tissue. Is there any black ones? Okay, I prefer to this one loading. We usually put some tape. Let's see. Anyway, this you can load this one, making some tape on here and then load on here. If you clamp this one, they can block.
Yeah.
Okay.
So we do some taping around here. Or do we have any pipette? Pipette unpulled.
Oh, unpulled pipette.
Unpulled pipette.
Oh.
Just give me one. This one is open, right? So when you get the one, don't open this one. Just here, because this already we made it here. Oh. Because to prevent any dust coming in there. So how you can do it? We can make this together and then tape.
To
Like
make
this
it
one?
sturdier.
Yeah, like this way.
Stability.
Is there any tape? Yep. No. Yep. I think this can support you, right?
Yeah.
Make. Not this. So. Yep. Yeah. This is. See what is coming here. See.
Yeah.
That's enough. It doesn't matter. This can be vibrate because it's perfusing thing. It's big one. If it shake, it doesn't affect anything. So this length, I bet this one should be short. If it's long, it can be make vibrate the teeth
Yeah.
to make better, worse for patching. But this one perfusing is big enough for covering the area you perfuse. So this length enough, and then you don't need. This is enough to. You don't need tight, too much tight holding this one. So this is still fine because it's perfusing thing.
Yeah.
Right? So I think depend on where you. I think it's okay. You can make it measure the length by this way, either way. Okay? Positioning on top of the around near the center of the objective. So when you use this one, I recommend you use this this one on the bottom here. And let the drop in this onto here inside here. Don't drip here. Yeah, I think it's a lot dripping here. It's here, you see. That's bad. So put here and then dripping to here
Okay.
while you're setting these things. Right? So here, so as you see now, you may see it's fast dripping. It's as you visibly it can coming out within 5 seconds. You can see some drip. What is it?
Droplet.
Yeah, droplet in here. So that is actually very fast. Perfusing.
Okay.
So what you need to do is when you load this one, and it is kind of dripping for at least 10 minutes, around 10 minutes. Leave there because they can make all air coming out.
Okay.
This at least the first.
So before
dripping.
starting, we need to leave it for 10 minutes.
Yeah. So the best way you must do is you have to remove all air inside this tubing from here to here. All air must be removed. By this way, you can remove the whatever air. Okay, and then now we have to do third one, right? Same time. So close the first one. Just check this one and then make sure this is out, and then you can turn off the first one. And then let's do the third one. Check whether it's coming out or not. So third one, we close the front this way. So now it's on, right?
Yeah.
So leave and then see it. This is maybe more faster than the first one. See, you can see air bubble,
bubble.
coming out.
Oh, yeah.
Because we increase the pressure high at this moment because to remove the air fastly. So increase the pressure first,
Yeah.
and then do this job.
So when you are done, you can then
When you
reduce
done the experiment, you need to also remove these things, right? So also increase and then do this one.
Okay. So
Cleaning, that's cleaning job.
right now it's at like 2.75.
As early, as high as possible, like around the 3.
Okay.
So when you finish cleaning and you running the experiment, you can now reduce the
Yeah,
pressure,
while
so
you do experiment, you have to adjust the pressure, low
So-
down, because this is too fast
Yeah.
for your perfusing.
Okay.
But that is another delicate job. How much you reduce?
Mhm.
To reduce, it is not coming out.
Yeah.
Oh.
Too
So
high,
low.
it is too fast. That's
Average.
you have to delicately control that one.
Yes.
See, nothing coming out, right? Nothing. What can you do then? Because we didn't remove this one yet. First, we forgot to do this one. We have to fill first air or solution with this way first. We didn't do that, right? This one first. See, now dripping, right? Make sure this one is not clogged. This one is not clogged. After that, we have to install the tubing.
So that initial flow is to let opening of the passage of the tubing.
So you need to fill the solution first from here to here first.
Yeah.
And then this one is long but it's thin. So make sure this one is first running properly. This much. So that way, to do that, you need to remove this tubing,
Oh.
and then see it dripping somehow.
Oh.
If it is expensive one, just 1 or 2 drip enough. You don't need too much dripping.
Okay.
Okay. So now this much, at least this much is filled, right? We
Yeah.
fill the tubing from here up, at least this much.
Yeah.
Now let's fill in the tubing. Then turn on the 3 and then see. Sometimes this tubing was stayed for too long time without any cleaning, and then it's clogged happen. Then we have to replace this tubing.
Oh.
Nothing. Something like maybe this one is now inside there. Tubing was clogged.
No.
Could we push distilled water?
So what I need, what I do is instead of using this one, this air pressure, I do like manually pressing. In that case, we have to be hold this one. Sometimes it's push,
Push. Oh.
Okay.
coming out. So I hold this one, and then hold this one together.
Okay.
Oh.
Okay, it's coming out easily. I hold and then manually. Can you see?
Mhm.
Now it's coming out, right? At least
Yes.
you need to do this job if you are not using for a long time. But if you clean very well at the end of experiment, every experiment,
Yeah.
it won't take this much long.
Yeah.
So I do manually, maximum, because my pressure is higher than that one.
Yeah.
And then we can do back to here. And then or use the actual pressure of this one. I'm gonna close this one just for applying to this one. I didn't close, but I close now. See, now because it has some remaining of pressure, because this rubber,
Mhm.
this can be expandable. After this one, you have to stabilize the pressure by using only this one, because this one is hard enough, but this is very soft. It can be expandable. Some pressure can be remained in there, even though you remove this one. So you have to wait. That's why you have to running for at least 5 minutes or 3 minutes. So now it's running out, coming out. So wait until it is stabilizing. How fast this flow? How fast this flow? You have to calculate. How to that?
Second, how
Using
many?
the
Timer.
what is the PCR tube, small tube. You have PCR tube, small tube.
Yeah.
Doesn't need to be sterilized. Just I need an empty one, anyone. Any PCR tube. Either that one or that one. That's fine. This was fine. I need that. Okay. So this one, the way you calculate how fast this flow rate
Mhm.
is, okay, you can you have to have timer.
Timer.
Okay, Rebecca, timer, with the timer, not the one, timer, okay,
Not
phone
phone,
time.
Yeah.
On your phone.
like 1 minute, okay, ready? We have to collect this one for one minute or 5 minutes. If 1 minute too small, 5 minutes or that's it. Okay, so I just removed and then collecting from that point. Can you do again?
Yeah.
Okay. When you're ready, you know. Okay. Ready, set, go. Like this way. So we can measure the volume of this water
Okay.
for 5 minutes or 3 minutes, something like that. It's 1 minute is too small amount. And then how can you measure this one? Using pipette,
Right.
right?
Okay.
Maybe 100 or 200 microliter pipette. You can just sucking up with known value, sucking up. If not, then change the value until it is all sucking up.
Yeah.
That way you can measure
Okay.
how
Like
much
how
it
much,
Know the
it
volume.
has here.
Could we weigh it too?
We can weigh, we can do that,
Mhm.
but we can using pipette.
Okay.
See, this one 200 microliter or 10, 200 microliter is too much. Maybe 10 or 20.
Mhm.
I think 20 is okay. Using this one, pipette, right? So when you collect with, let's say here 20, 10 here 10, right?
Mhm.
When you collect 10, still remaining, so you can increase it 20 and you collect remaining, nothing
Yeah.
remain. That is that much
Okay.
volume.
1 minute is done.
Okay. So okay, around this one. So let's just drop that much. Right? So this much volume, right? You see that? Can you see?
Yeah.
So using some pipette, where is the 20? Which one is 20? This one? 10. Let's say 10. Not this one.
This one.
Where is 20? 20 pipette.
This one at tips.
Where's the 3? No. Let me do 10. Okay. So I'm gonna measure 10 now. The 10. Okay.
Yeah. 10.
10.
20.
Okay, it's okay. 10, right?
Yes.
So I'm trying to collect 10. My eyes not. It's not enough, right?
No.
Maybe this is 20. I need 20 pipette.
Here.
I have pipette, but I need
Oh,
tip.
tip.
That tips.
I think it's these ones. Here.
Yeah.
Let's say 20. 20.
No, it is still
Bubbles.
something is somewhere is there.
More than 20,
More,
right?
yeah.
I think 100. We need 100 pipette. 200, okay, here, 100. Okay, 100. Less than 100, right? So it's 100 is too much. Now,
70.
60. 60 is too much. Almost
50.
50.
I think about 60. So like this way, you don't need the exact calculation.
Yeah.
So about 60 microliter per minute,
Yeah.
right?
Yeah.
That is the flow rate. So you can do this way to calculate the flow rate. But that is very high, very fast flow.
Okay.
Okay.
So we can adjust the pressure.
What's the ideal flow rate for?
I have no number,
Okay.
okay? But absolutely low than that much. So,
I just put a pressure to.
no, let me try. So what I'm thinking, with this one, how fastly you can make it drop? Let's see, count. You just drop, yep, you have to increase.
2, 3.
Maximum, yeah. So we can just see visually count how long it takes to drop in.
Okay.
Maybe once 20 seconds, maybe one drop. Okay, let's count. One, like this way.
3, 4,
You can manually count everything.
6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30,
Okay, so this is very fast. So okay, that takes too long time until waiting to dropping. So what I do is, if after I clean here, if I see until I visually see the drop by eye, okay, that is 5 seconds around there. By my kind of estimation, measuring here, 1, 2, 3, 4, 5, 6. Around 6, I see some drop.
Yeah.
Yeah.
My eye is there. You know, your eye is better than me. So you have to see. Okay, 6 seconds with the visual, that is very fast. Okay, so yeah, you can count like here, 1, 2, 3, 4, 5, 6. I see the 6. My eye is bad, but 6 I see something. So it is fast, very fast. So we have to drop and then reduce, and then making maybe 20 seconds. I see somehow something like that.
Can I make it 2?
Yeah, 2 reduce. Ready?
2 now.
Okay. It's barely because it is by eye microscope wide is very big drop. Actually.
Yeah.
So with the 20 second, 10 second, I have to see somehow. I barely see. Maybe too small. Low pressure. It's all barely see.
Yeah, yeah.
Can you see?
Yeah, yeah.
Yeah. That may be okay, but it's a little bit slow. Maybe 20, 15 seconds, 20, too fast flow making pressure already, or the flow pressure they stimulate the channel also. So we don't want to stimulate this by this flow rate by itself. We are stimulating the other way, right? So this one is minimum is best, but we are very careful. If it's minimum, maybe this one clog happens, something like the flow is not usually happen. When this works, but when you put into there, it may not work. And there's some clogging happen here because we didn't put in the distill, the filtered solution in here. Right? So this one is absolutely working because I see here it's working. So its flow is in here. So and then flow 3 and then let's turn on 1. If okay, this two flow rate is not always same. This valve or this tip or this tubing is good, better than this condition than this tubing. So means this one is not always exact same for both of the valve. Some valve last time this tubing was worse than the actually number 3. Number 3 works the best. So you have to, in that case, you have to reference this one. This must work, right? The slow flow must have making some flow. That much you have to reduce. Do you know what I'm saying here?
Yeah.
Because this tubing is not always same condition. Usually this one is better flowing than this one.
So we should match the flow rate.
So you have to adjust the flow to the low one first. Low one always. The low one always, both should be flow, right? But low one must be flow at least. And then that means this better one is much faster flowing, but also okay as far as the low one is working. But if you adjust pressure for the high or better one, and then this one not working, that means that bad experiment, because this one you perfuse correctly, but this one is not perfusing it. So always adjust the pressure to the worst tubing. The worst one should always work, and then better one. That means better one always absolutely work. Does that make sense?
Yeah.
That's the limit of this tubing perfusing experiment. It's not working at all. Turn, I did.
No.
Sorry, I did. So yes, so right, you're right. No, you have to leave it turn on because this valve, this is just for experiment.
So there is no need to specifically off this.
No. Because your valve closing open is now by this valve,
okay.
not this tubing. This valve is for preparing,
Yeah.
cleaning, or preparing thing. But eventually you are controlling the flow by these two. Make sure these two unused one must be closed at here. So no, this is bad. You see here, easy rotating. That's bad. Maybe air leaking here. So you have to tight seal and then close. Some air, if air is leaking other place except this one, air is leaking or some air other place, make sure. That means the flow is very slow. So make sure no air leak. Right? Yeah. So close. I did close, both close. So no air leaking. Make sure all valve is tightly sealed. Okay. And then you can load whatever solution. Now it's working. See, right? But some solution has more viscosity than distilled water. That may be less flowing. Okay, it works.
Yeah.
Right?
So when we do perfusion, it means like if we select one cell from that other side, we need to put this perfusion on the top of the cell, or
okay, cell is here. Okay, your perfusion tip is this must be.
okay.
This patch pipette is very tiny. This one.
Yeah.
Cell is here. Pipette tip is here. The perfusion tip is like this mouth, like this much.
Okay.
Very big compared to this one. This one is 1 micrometer. This tip is about 300 micrometer.
Okay.
This much you can perfuse. So wherever you are here, around here, as far as this direction, okay, let's say this perfusion pipette. Okay, let's say this is a perfusion pipette tip. Okay, here to here. So you perfuse this direction, like this way. Okay. Wherever it's far close, and then here, that actually affected here. I think more than this one, more than 4, like this one. Perfusion tip is this much. See, it doesn't matter how close, how far. That is enough to affect here, but not too far, because this area is so big compared to this cell and this pipette.
Okay.
And then when you do outside out, see, enough cover. You don't need to close this one. This one is still working. Around here is fast. You know what I'm saying? Yeah. This one is so big. When you flow this much.
So in the camera, if we put like, we just need to see. If we see is coming the perfume, we should stop there. We should not go deeper.
No.
If you see in the camera.
Let me show you. Can you bring the chamber with the cover slip?
Yeah.
Well, sealed. You need seal. You need, yeah. You need to put it.
It's gonna be like 10 gigabytes.
Like you do it like in parts.
Yeah, I can crop it.
Oh.
It's running.